I'm just so delighted to be here with all of you this morning, have an opportunity to talk about Australian metals manufacturing and why it really matters for Australia, yes, in economic terms, but in strategic terms too. Future Made in Australia is all about adding value to and protecting the wealth generated from our commodities in the face of fierce competition for control of supply chains and to shape a future Australia with a more resilient economy. The world's economies are racing to reduce their own emissions, and new markets for low emissions iron, steel and metals are emerging. Accenture estimated that low emissions iron could generate for Australia upwards of $122 billion per year in export revenues from 2040. Building this industry will help us boost domestic manufacturing and metals processing, creating better jobs, good jobs for Australians in our regions and outer suburbs. Japan and the Republic of Korea in particular, other North Asian partners, are looking to us for low emissions iron. Our task, and my task, is to drive the investment, facilitate the development and use Australian science to deliver it here in Australia. We have got an enormous job in front of us, stabilising our current industrial capability, building new iron industries, building low emission steel making capability, building world-leading renewable aluminium exports, the science, the technology and the capability of Australians in our national interest to build a more resilient, stronger and safer economy, and I know that you are all going to be powerful partners in that process. Thank you very much.
I might just shift across to the discussion about green energy, which is largely why you're all here. Chris, I might kick off with you this morning because your proposition with NeoSmelt is particularly interesting and is actually relevant, especially I guess to Dino, but also to the chamber. You're looking at building, a facility that makes the Pilbara a little bit more future-proof than it is. We heard the minister talking about, China possibly looking for higher-grade ores, which might put the Pilbara out of the picture. And as we all know, we can't afford the Pilbara to be shut down because of better ore options elsewhere. Can you just explain your projects to us in some layman's terms and what it is that you need to move forward?
Yeah, thanks. Yeah, so Project NeoSmelt's one of the most ambitious industrial decarbonisation projects in the world. It's underway at the moment. What it is it's a project that's looking at how do we decarbonise steel making, but particularly iron making. And the way that we're doing that is through a different process called DRI, direct reduced iron, into an electric smelting furnace. Now, that's a new pathway for iron makers, but why it does, and the reason that we're doing it this way, is that at the moment there isn't a pathway for Pilbara ores other than the blast furnace, which is high in carbon emissions. So by doing this, we're able to, by using natural gas, use existing technology and reduce steelmakers' emissions by around 60%, while also creating a pathway where you can use hydrogen or CCS in the future to further decarbonise that. And what that does, what we're doing in the project is we're aiming at targeting it specifically for Pilbara ores. I mean, the risk being that, as the blast furnaces in the next decade are going through that investment phase of reline or replacement, we need to give them an option during the 2030s that they can actually go to a technology which is amenable to Pilbara ore. And that window is really narrow. We've got to do that now. And so that they're able to have, what we're going to develop is investment grade data that they can then build a commercial plant with. So this is a demonstration plant of that technology pathway, which they can then use to design and build their commercial plant.
Now, Chris, the upside on this is relatively large, isn't it? You've talked about 60% reduction. We're talking about furnaces accounting for 8% of the world's emissions, which is no small number when you're talking about the entire globe.
That's right.
So the upside on it is relatively large. What exactly are you looking to do, and what do you need to go ahead with it?
So at this stage, like we're in the feasibility phase. We're aiming to sort of get to FID at the end of the year. I've got some. I think if you're thinking about a project which is going to make a difference and make a difference before 2050, this is the project. I mean, this is the one. I've got partners across the value chain. We've got BHP, we've got Rio Tinto, we've got Mitsui, and we've got Woodside. So we've got steelmaker, miners, energy company, trying to solve that problem in a way which is responsible, but is also going to be effective in giving people that option. So we are looking, at taking FID later in the year. It's, we need to keep all the partners together. I'm open to more partners if there's anyone else out there. But certainly, the government support is critical of this. I mean, Pilbara, as Minister Ayres mentioned, is the largest export industry in Australia. So we're looking for a few $100 million to be able to secure that 120 billion per annum industry, all the royalties, the taxes, the jobs, sovereign steelmaking capability for BlueScope. So these are all the things that this project is designed to resolve.
And in a very quick answer, how much do you need from the feds to kick into this to get it over the line? Yeah,
so look, it is a demonstration plant. I mean, we're looking for several hundreds of millions of dollars to do that. But we are, all the partners involved are also contributing to that as well. So it's really important, like not only for our partners, but before the government, that provides the catalyst for us to be able to take on such an ambitious project, which doesn't just sort of decarbonise for a single steel plant. It's looking at reshaping the future of global iron making. I mean, this is really significant, and then it's only in that context where government support is absolutely critical.